Okay, I got cut off. I forgot that my limit was just 5 minutes. So let's continue. Zero property, anything to the zero property is 1. If it's all in parentheses, it is 1. Let's say you have 3x to the 0 power over 5. Then everything in the numerator right here equals 1. This is just equal to 1/5. Okay? And that's your zero property. Okay, and the last thing we did, I meant to set a timer for myself so I don't get cut off this time, is negative exponents. So the general rule here is if you have a negative exponent in the numerator, because technically you can make anything a fraction, right? I could put a 1 under this and make it a fraction. Right now that's in the numerator. If we want to simplify this negative exponent, we need to put it in the denominator, and that makes our exponent positive. So what's up here in the numerator? Well, this little understood 1 that's also there stays up there. So x to the negative 2 is the same as 1 over x squared. 2 to the negative 3 is the same as 1 over 2 to the third, which we can simplify further to 1/8. Both of those are equivalent. Okay, and then it also works the other way. If you have a negative exponent in your denominator, in order to make that negative exponent positive, you need to move it to the numerator. So 1 over x to the negative 2 would equal x to the positive 2. If we had 2 over x to the negative 2, we would still move this up, but it would have that 2 as a coefficient in front of it. You only move things, you only need to simplify things if they have negative exponents, if you're being asked to simplify. If we have 10x to the negative 3 over 5y to the negative 4, we have coefficients this time. This is division, so you would divide your coefficients. 10 divided by 5 is 2. Now, we can't subtract these exponents because these bases to these powers are not the same, but we can make our exponents positive. Y to the negative 4th needs to go up, x to the negative 3 needs to go down. So y to the 4th would come up here with the 2, and x to the 3 would come down here with, by itself, because we simplified. Okay, so that's a quick review of everything so far. Now, in the upcoming days and next week, we're going to be talking about radicals. When I say a radical, I'm talking about this little symbol right here, and you're probably familiar with that. For example, the square root of 4 is 2. And why is that? Because 2 times 2 is equal to 4. So we're going to be talking about perfect squares. We're even going to be talking about perfect cubes, like the cube root of 27. This means what number times itself 3 times gives you 27. Just like up here, this was what number times itself twice gives you 2, gives you 4, What number times itself 3 times gives you 27? It's 3, because 3 times 3 times 3 gives you 27. So we have another understood number right here, just like there's a 3 here that we actually put, and we call this the cube root. We don't put the little number here, but there's an understood 2 right here. We call this a square root. So we're going to be talking about models of perfect squares. We're going to be talking about solving equations, like if y squared is equal to 100, what does y have to be? So you can use common sense with that, but we're going to dig a little bit deeper into it also. So that's next week, and my time limit is about up, so I'm going to stop and make sure you guys can see all of this.